Hello, Legacy students. Marsh here. So today we're going to be changing between radical and rational exponent notation. Things you're going to want to have on you: your notes, the foldable I gave you, the notes that I gave you, pencil, roots card, and then also you're going to want a calculator today. Some kind of calculator that you're comfortable with. That is a graphing calculator, that is a scientific calculator, anything that you are comfortable with and you will be using on a learning check. So first thing, we need to talk about the notation that we're going to be using today. We're going to be using radicals and also rational exponent notation. Now, we have talked about a radical. You have seen a radical before. A radical is what we considered like a square root, right? Well, the technical term is a radical, and there are pieces to the radical that we need to identify. First thing we have is the number on the inside. The number on the inside is the radicand, is what we're going to call that. And then there's sometimes a little number sitting out in the front. That is the index. Now, the index tells you what kind of root it is. So if there's a little 3 here, then we would call that a cube root. Now, if there is a 2 for the index, we don't write that. That is because we, as a math society, have decided that the square root is the common root. So we don't write a little 2 on the index if it is a square root. We just assume that there's a 2 there. And then the other one on a kind of notation we have is a base to an exponent. And that exponent today will, in fact, be a rational exponent or a fraction exponent. So we're going to get comfortable with changing between these two notations today and how to evaluate them. Now, I need to have a conversation about different powers, roots related to fractional powers. So I'm going to give you some of these values, and then you're just going to kind of hypothesize how you think these numbers are coming. So 25 to the 1/2 power, I'm going to tell you that is 5. 36 to the 1/2 power, I'm going to tell you that's a 6. Now you're probably thinking, Marsh, this is suspicious. 49 to the 1/2, you're right, it's 7. And 64 to the 1/2, yep, it's 8. So here is what's happening here. 25, square root of it is 5. Square root of 36 is 6, and so on, right? So what we're saying here is that if I take a number to the 1/2 power, I get its square root value. I wonder if the same thing holds with a 1/3 power. So I'm going to tell you 8 to the 1/3 is 2. And I'm going to tell you that 64 to the 1/3 is 4. Now you're like, Marsh, I don't know about those. Well, here's what I'm going to tell you. 2 to the 3rd is 8, because that means 2 times 2 times 2. Yep, that's 8. So same thing holds, that if I take the cube root of 8, see the little index of 3 there, we get a 2. And if I do the cube root of 64, we're going to get 4. So same thing holds. If I take a number to the 1/3 power, I'm going to get its cube roots value. Now, let's write this in our notes. What does it mean when I have a fractional exponent that is a 1/2? Well, we said that means we have a square root, and its radical notation looks like this, square root of x, right? And we did say earlier that technically there is an index of 2 out there, but we just don't write the 2. Now, is it wrong for you to write the 2 right now? Technically, no. You could write it there if it helps your brain understand that that is a square root. If I have x to the 1/3 power, that means we have a cube root, which means a radical notation, my radicand being x. My index is a little tiny 3 sitting out front there. And then what about x to the 1/4? Well, that would be a 4th root, and it would look like this in my radical notation, 4th root of x. Same thing, 5th root, 6th root, so on and so forth. Now, what about something that's like 8 to the 2/3? I want to be able to evaluate that. I want to be able to write it in rational and with a radical, because right now it's in rational exponents. Well, we have that ability. So when I'm in radical form, that means I have a radical sign. If I am rational exponent form, that means I have an exponent that is a fraction. And I want to be able to be comfortable to swap between the two forms. So if I am in rational exponent form, aka exponent as a fraction, I can rewrite this as a to the 1 over n to the m power. Because remember, our exponent rules. If I have a power to a power, we can multiply these two, right? Which, if I do 1 over n times m, put them over, multiply both, I'll get m over n, right? And we said a to the 1 over n back here, we said that's just the root with that denominator as my index, right? So I can write the base with a root of the denominator. And that m is just going to still sit out in the front. And I know it's kind of creepy looking, kind of scary looking. But once we get used to it, you're going to get so used to this pattern, it's going to become second nature. So let's try a couple of problems. First thing I notice is that this guy doesn't have a number on the out front, but I'm still going to show that simplification or that separation. So I'm going to show that I'm going to do 7 to the 1/2 to the first power. So I'm going to distribute, I'm going to take that numerator and put it outside the parentheses. And then I'm going to change 7 to the 1/2 as the square root of 7. And again, it's not wrong to put a little 2 out there to the first. And that is changed. Let's try this one. So again, I'm going to change it to 4 to the 1/3 to the 4th power. So I just broke that numerator and put it outside. Now I'm going to change 4 to the 1/3. So that is the cube root of 4. And I still need to that 4th power sitting out front. We're going to do the same thing to this guy. So 2 to the 1/3 to the 5th power. That means I would have the cube root of 2 to the 5th power. Not terrible, right? Go ahead and try these 3. Pause the video here. Try these 3 and see if you can get the answer. I'll wait for you. Did you try them? Or are you waiting to see if I'm going to try them? Please make sure you pause and try these problems. All right, I'm going to assume you tried them. So here's the answers that we should get. We should have gotten the cube root of 7 to the 4th power, because again, we could break this into 7 to the 1/3 to the 4th. And sometimes you might not even need to show this anymore. You might just figure out the pattern. Because I always find that the denominator becomes the index, the numerator becomes the number on the outside, honestly. So I would get square root of 6 to the 3rd and the 6th root of 2 to the 1st. And technically, we don't even need to write to the 1st. We can just read it as the 6th root of 2. Let's go backwards. Dun, dun, dun. Now, first thing, I do need to put a little index of 2 out here so I can see that little index. And what I'm going to do is rewrite the inside. We said the square root of 10 is the same as 10 to the 1/2 to the 3rd. Now I can multiply my exponents, and I will get 10 to the 3/2 power. Please make sure that that looks like an exponent. It's kind of difficult, I know. Technically, there's a 1 sitting right here. We just don't have it written. So I'm going to change the 6th root of 2 is 2 to the 1/6. Technically to the 1st, which is 2 to the 1/6. Now I'm going to change the inside. That's 2 to the 1/4. Because that's 4th root of 2. And then I'm just going to multiply. So 2 to the 5/4. Now, try these 3 again on your own. So pause the video for me. Okay, I'm assuming you're pausing. Otherwise, you just heard a lot of silence. So let's go ahead and convert. This is 2 to the 1/3. This is 10 to the 1/6. And that is because there's no exponents sitting out there. And this is 10 to the 7/3. Not bad, right? Now, how do I find the values in the calculator? How, Marsh, do I actually evaluate these? Now, if you're using a scientific calculator, this is the most common one, a TI-30X2S. What you're going to want to do is you're going to want to type the index first. Okay, so in our case, we would type a 3. And then you're going to push the second button. Oh, I'm going to change my color here so you guys can actually see it. You're going to push the second button. And then you're going to push the caret key right there. And what you should get up there on your calculator is you should get x square root. This x is what's going to be giving you that 3 as an index. And then inside, we're going to put parenthesis, -8 parenthesis is what we're going to type there. If we do that, we should get a value of -2. Now, you may have a different calculator. What you are going to be looking for is this kind of button. It might be in a second command. It might be in a menu somewhere, but that is what you're going to want to be looking for. If you have a different calculator and you cannot find that button, please let me know. I will definitely find it. Most calculators have it. If not, we're going to be talking about another way to evaluate here. Please try 4th root of 625. So then again, I'll type a 4. I'll click second. I will click exponent. It'll give me this little guy. And then I'm going to type parentheses, 625, parentheses, and that should give me a value of, I believe, 4. It's been a hot minute since I've evaluated that one. Here, hold on. Let me go grab my calculator. Oop, I lied. That's a 5. That's why I should always do my math ahead of time. Now, let's say you have a graphing calculator. Here is how you're going to accomplish that. Let me pull up my graphing calculator here. So first thing you're going to want to do is you're going to want to get your graphing calculator into the normal mode. So I'm going to go second quit. You want to be in your normal menu. Now, what you're going to want to do is you want to go to the math button right here. It's right below alpha. And what you will find is many different combinations. Now, I have a cube root, so I could go down to number 4. However, number 5 is the general root button, so that would be your best bet if you're not sure on the root. But this is a cube root that I want, so I'm going to scroll down to a cube root, and I'm going to click 4. And notice the little 3 popped up. Now I need to type in -125. Enter. I'm going to get an answer of -5. Now, 5th root of 32, again, I'm going to go to math. I'm going to scroll down to 5 this time because I want the little X there. And now I'm going to give 2 boxes. I'm going to type a 5 and then a 32 for my radicand. I'm going to get a value of, whoops, didn't let me write, a 2. Okay? Now, personally, I hate finding those radicals because they are quite hard to find. I like using exponent notation. So if I'm given something in radical notation, I convert it to rational exponents first. And then I evaluate. Because here's the thing. I know how to do powers in the calculator. We have done powers for years in the calculator. So here's what we can do. We can go 256 caret key, the exponent key on your button, parenthesis 1 divided by 4, parenthesis. What you will get if you do 256 to the 1/4 power, you will get a value of 4. Same thing, 32 to the 1 divided by 5. Again, this is that caret key on your calculator. You will get a value of 2. Kind of different, right? However, I find that it is much easier always for me to be able to do that on my calculator. What if I don't want to evaluate with a calculator? What if I want to do without? That's where that perfect roots table that you guys are so comfortable with or we're going to be using, that's where that's going to come into play. So go ahead and grab that out because we're going to be following it quite a bit here. So first example I want to do is 25 to the 3/2 power. What I'm first going to do is I'm going to convert it to radical notation because this is harder for me to work with. So that means that would be the, square root of 25 cubed. So now, here's what I'm going to do. To use my perfect roots chart, I'm first going to figure out what is the square root of 25, which means I need to start in the squares column, which means I need to now find the 25. I'm going to do a little bit of cleaning because I think I have this all popping up. There we go. So I want perfect squares. I want to get down to 25, and I'm going to find that to be a 5. So that means I now have 5 cubed. So now I'm going to look at the 5 row and the cube row and see where those two line up. And I'm going to get an answer of 125. Okay. Same thing for example number 2 here. I'm going to get myself, I'm going to change it into, that is the cube root of 125 to the negative second power. Now, cube root of 125. I'm going to start in the cubes column because it's cube root and find 125. I'm going to go over and find that to be a 5. So that's 5 to the negative second. Now you're like, but Marsh, we don't have negative exponents on here. That's okay. A negative exponent means bottom of the fraction, right? Wrong side. Get me out of here. So I'm going to flip that around. So that's going to be 1 to the 5 squared. So then I'm going to start in the 5 column, square column, arrows, hit 25. So this is 1 over 25. Let's try example 3. So I am already in radical notation. I don't have to change it, but I'm going to start in the 5th power column. I'm going to go down until I hit a 32, and then I'm going to go over until I hit a 2. So this is technically 2 to the negative 2. I'm going to change that so it's 1 over 2 squared. Then 2 squared is 4. So this is 1/4. Go ahead and try this last one for me. Kind of difficult, a little different. And you're probably like, well, Marsh, there's not a cube root of a negative 27. Well, here's the thing. So I want a cube root of 27. That is 3. And since it's a negative, it's just a negative 3. Because square root or cube roots are fine. Square roots give imaginary. Cube roots, you can actually have negative numbers. That's because negative 3 times negative 3 times negative 3 is negative 27. Now I got to go negative 3 squared. We know that to be a 9. So that perfect roots chart, if you get comfortable with it, definitely can be a little bit faster than using your calculator. It's kind of clunky on the calculator. And that is the end of this video. We are going to be practicing and working with this, changing between the exponent and radical notation quite a bit. We're going to get very comfortable with it throughout this unit. But thank you for watching the video, and I will see you later, Sabers.